In this video, we will be demonstrating Techquipment's hydrology and rainfall apparatus, the H313, for the practical study of hydrology, including rainfall and the movement of water over land and rivers. For the design of flood protection and for assessing water capacity for irrigation purposes, it is very important to understand in detail the section in the hydrology cycle where rainfall occurs, creates runoff and then travels into a stream flow such as a stream or river. In particular, it is the quality of the runoff and the various factors that affect this that students can study with this piece of equipment. The rainfall runoff process is fairly complex and is affected by a range of factors. The initial wetness and permeability of the catchment area, i.e. the area where the rain falls, plays a major role. Rain falling on a very dry, permeable catchment will tend to infiltrate the soil rather than move across the surface to the river. On the other hand, rain striking a wet, impermeable surface, such as rocky ground, will result in a high proportion of runoff. The intensity of the rainfall, whether it be slow drizzle or a mass downpour, plus the slope of the catchment, will also affect the quantity of runoff. This equipment allows you to investigate rainfall runoff relationships for dry, saturated and impermeable catchments of various slopes. In total, this piece of equipment is 2.4 metres long, 1.8 metres high, 1 metre in depth and only requires a mains electrical supply. It is also self-contained, as you can see with this piece of equipment here at the University of Nottingham. This large, sturdy metal frame holds a large rectangular stainless steel tank, which acts as the catchment area, which can be filled with a granular medium, such as the stand we have in here. This forms a permeable catchment area. Below this is the plastic reservoir tank. A jacking mechanism allows you to adjust the angle of the catchment area. A series of spray nozzles on the top simulate the rainfall. To allow you to simulate a moving storm, all the valves, or just half the valves, can be turned on. At each end of the catchment area are end compartments that are separated by weir plates with porous potholes. These can be opened to drain water or supply water to the catchment area from the end compartments. In the middle are two wells and a range of piezometer tappings in the base of the tank. These can be used to understand the drawdown of a single or both wells, and separately to feed water to the aquifer rather than by using the overhead sprinklers. Experiments include demonstrating dewatering of excavation sites using wells, or the flow from a well in a confined aquifer. It also allows you to examine watersheds for a simulated island with rainfall and well flows, plus measure the cone of depression for a single well compared to that of adjacent wells. Further investigations include the ability to examine loose boundary hydraulics, the tendency of rivers to meander, the transport and deposition of sediment, studies of scour around simulated bridge piers, and demonstration of erosion caused by water through flow. This pump takes water from the reservoir and feeds it to the overhead nozzles and to the ends of the catchment area. Here you can vary the flow of water, and on this meter you can measure the overall flow. To measure the water from either the wells or the tanks on the end, we have a rectangular notch weir here just underneath the catchment area. The hydrology and rainfall apparatus is part of a range of hydrology engineering teaching equipment from Techquipment. For more information, click on the link in the description box below. Thanks for watching.